Hello everyone, this is V. Srinivasa, working as assistant professor in mathematics in Mlritm. So continuously I'm doing some PPTs regarding these multiple integrals. Last two videos I explained multiple integrals, that is double integrals in Cartesian form. How to evaluate double integrals in Cartesian form. So in this today's session, I will explain evaluation of double integrals in polar form. Sometimes polar form means here we have two types of questions we will see in double integrals. So here some questions are in terms of x and y, that is a Cartesian form problems. Some questions are in terms of r and theta, that is polar form problems. Suppose we have to take circle, that is what is the equation of the circle. Already learned in the lower classes, students learn in the lower classes. Circle equation is x square plus y square is equal to r square, that is a Cartesian form. So whereas in polar form, x is equal to r cos theta, y is equal to r sin theta. So here two forms are there. In today's session, I will explain about evaluation of double integrals in polar form. So here I will explain with some problems. The first question is evaluate integral 0 to pi by 4, integral 0 to a sin theta or square root of a square minus r square dr d theta. This is the first problem we are going to solve. So it's very easy to identify. Here two integrals are there. One is in terms of theta, another one is constant. So here r is a radius, theta is the angle. We know that that is magnitude and amplitude. So here r limits are 0 to a sin theta. Here only one way, r in terms of theta is constants. Otherwise both are constants. Two types of problems we have to see. So in this question, r in terms of theta. So here I is the given integral, that is integral 0 to pi by 4, 0 to a sin theta, r by square root of a square minus r square dr d theta. This is the given question. So this is 0 to a sin theta is the r limits and 0 to pi by 4 is theta limits. First we will do with respect to r, keeping theta terms constant. With respect to r, keeping theta terms constant. Finally, we have to do with respect to theta. So here there is a formula involved here, r by square root of a square minus r square. Now I want to use the formula integral of f dash of x into f of x power n dx. So this value is f of x power n plus 1 by n plus 1. Integral of f dash of x into f of x power n dx. Formula is f of x power n plus 1 by n plus 1. So here it can be rearranged as integral 0 to pi by 4, 0 to a sin theta, r into 1 by square root of a square minus r square. 1 by square root, how to write? A square minus r square. Square root means power 1 by 2. 1 by square root means power minus 1 by 2. So power minus 1 by 2 dr d theta. So if I take a square minus r square is f of x, its derivative is minus 2r. But here r only there. So we require minus 2. That's what multiply divide with minus 2. So here I am multiplying dividing with minus 2. Minus 1 by 2 minus 2. Now it is exactly in the form of f dash of x into f of x power n dx. So here that is equal to minus 1 by 2 is constant right outside, integral 0 to pi by 4, this is f of r, this is f dash of r. So f of r power n plus 1, that means a square minus r square power n plus 1, that is minus 1 by 2 plus 1 by minus 1 by 2 plus 1 within the limits 0 to a sin theta d theta, within the limit 0 to a sin theta d theta. So minus 1 by 2 plus 1, that is plus 1 by 2. This becomes minus 1 by 2 into integral 0 to pi by 4. Integral 0 to pi by 4. So a square minus r square power 1 by 2 by 1 by 2 by 1 by 2 into d theta. This 1 by 2 cancel. We get minus integral 0 to pi by 4. Power 1 by 2 is nothing but square root. Square root of a square minus r square d theta. So here with respect to r completed, now we have to do with respect to theta. Theta limits are given as 0 to pi by 4. So this is, so apply the limits, within the limits. After applying the limits, we can integrate 0 to a sin theta. So this is 0 to a sin theta. Here first upper limit is a sin theta, where we have to apply in place of r, we have to substitute upper limit as a sin theta and lower limit is 0. So that is equal to minus integral 0 to pi by 4, 0 to pi by 4 square root of a square minus, I am writing in place of r a sin theta, upper limit, that is a square sin square theta. This is upper limit minus lower limit a square minus, in place of r I am substituting 0, 0 square whole bracket d theta. So that is equal to integral minus integral 0 to pi by 4. So here I am taking a square common. So a square outside, this is a, and 1 square root of 1 minus sin square theta. 1 minus sin square theta is cos square theta. Square root of cos square theta is cos theta. So here in the second term, root a square is a. Already I took a common, then it becomes 1 minus 1 into d theta. So this is minus a into integral of cos theta d theta. Integral of cos theta is sin theta minus integral of 1 d theta, that is theta, within the limits 0 to pi by 4. Now we should apply the limits of pi by 4 as upper limit and 0 as a lower limit. So that is equal to minus a into, first I am writing upper limit, that is sin pi by 4 minus pi by 4. So this is upper limit. Lower limit sin 0 minus 0. So here we know that minus sin pi by 4. Pi by 4 means 45 degrees. Sin 45 degrees 1 by root 2 minus pi by 4. And sin 0 is 0. So when I take this minus inside, a into pi by 4 minus 1 by root 2. This is the answer. Once again, here this is the double integral in polar form. Polar form means particularly the problem is expressed in terms of r and theta. So here r limits, theta limits given clearly. R limits are 0 to a sin theta and theta limits are 0 to pi by 4. So here first we have to do with respect to r keeping theta terms constant, because r is given in terms of theta. So here the most important thing is which formula is involved here we have to identify. It is very easy to identify f dash of x into f of x power n dx. So in terms of x, but the problem is in terms of r, that means f dash of r into f of r power n dx. That is f of r power n plus 1 by n plus 1. I applied that formula, but here in order to apply that formula we require minus 2r, because a square minus r square derivative is minus 2r. So here minus 2 is not there, that's what multiply divide with minus 2. So minus 1 by 2 into minus 2r, a square minus r square whole power minus 1 by 2 dr d theta. So then power n plus 1, minus 2 plus 1 becomes 1 by 2, 1 by 2, 1 by 2 cancel, then we get power 1 by 2 is nothing but square root. We have to apply upper minus lower limits. Upper limit is a sin theta, lower limit is 0. When I apply a sin theta as upper limit in place of r, we get the square root of a square minus a square sin square theta. In second term, this is lower, that is lower limit, a square minus 0 square, that is square root of a square. When I take a square common, that is under square root a square, out of square root a. So square root of 1 minus sin square theta is root cos square theta, that is cos theta. Minus under root of a square becomes a is common. Here I took a common, then it becomes sin theta cos theta minus 1. So now we have to integrate with respect to theta. So integral of cos theta is sin theta minus integral of 1 d theta is theta. Then finally I have to apply the limits of 0 to pi by 4. So here in place of theta I applied upper limit pi by 4 sin pi by 4 minus pi by 4 minus lower limit to sin 0 minus 0. Sin 0 is 0 and sin pi by 4 is 1 by root 2. 1 by root 2 minus pi by 4. So outside minus is there, that should be taken into inside. Then a minus b becomes b minus a. Then that is a into pi by 4 minus 1 by 2. This is the one problem. Similarly, I will explain with one more problem. So here in the last problem, in the last question, limits are given in the integral. So now we will discuss when the limits are not given, some region is given. So we have to evaluate double integral in polar form. When the limits are not given, region is given. So how to do that? That simply by drawing the rough sketch, we have to identify the limits from the given region. Then as usually we have to integrate with respect to r and then with respect to theta. So look into this problem. Let I stands for integral. Let I is equal to double integral of r sin theta dr d theta over the cardioid r is equal to a into 1 minus cos theta above the initial line. Here x-axis, y-axis. Generally in Cartesian form, this is x-axis and y-axis. Whereas in polar form, these names are changed as this x-axis is nothing but x-axis is initial line. X-axis is initial line. And y-axis is perpendicular line. Y-axis is perpendicular line. So x-axis and y-axis names in Cartesian form, that same names, whereas in polar form we call as initial line and polar form. And in Cartesian form this is called origin. In polar form this is called a pole. And come to the distribution, this is theta is equal to 0 degrees. This is theta is equal to 90 degrees. This is theta is equal to 180 degrees. This is theta is equal to 270 degrees, 3 pi by 2. Again, if we reach 0, this is theta is equal to 2 pi. So, one circle means 360 degrees, 0, 90, 180, 270, again 360. So, this is a distribution of angles in polar form, and x-axis is called initial line, y-axis is called perpendicular line, the origin is called pole, right. Now here there is a cardioid, r is equal to a into 1 minus cos theta. So first we will take initial line and perpendicular line is nothing but x-axis and y-axis. So r is equal to a into 1 minus cos theta. So here suppose this is x, r is equal to, we have to find r value when theta is equal to 0. When theta is equal to 0, cos 0 is 1. Then a into 1 minus 1, that is 0, r is equal to 0. When theta is equal to 180, so that means it touches here. That means it touches here. When I substitute theta is equal to 0, r value is cos 0 is 1, 1 minus 1, 0, r value 0. So that means the arc starts here, and where it touches, this is theta is equal to 0 line, theta is equal to 90, and where it touches the theta is 180 degree. So where it touches, suppose if I substitute theta is equal to 180, cos 180 is minus 1. So minus plus 2a. So that means it touches at the point 2a. So this is the figure. This is the cardioid. So this is the cardioid. This is the point 2a comma 0. Right. Now here coming to the cardioid, we require r limits and theta limits. Clearly r limits are given r is equal to 0. Why r is equal to 0? Whenever theta is equal to 0, theta 0 is substituted here, we get r is equal to 0. So that's what here r limits first. I am writing r limits 0 to this cardioid equation a into 1 minus cos theta. Right. This is r in terms of theta. Then theta limits. Theta limits how to find? This is the theta starting point. Theta limits, this is the theta starting point. That means theta 0 and it touches and theta is equal to 180. So theta limits are 0 to 180. Theta limits are 0 to 180. So these are the r limits and theta limits. This is the way of finding limits. Whenever limits are not given, the region is given through the rough sketch. So next, what is the integrand given? R sin theta dr d theta. First we have to integrate with respect to r. First we have to integrate with respect to r, keeping theta terms constant. So sin theta is constant. That is equal to integral 0 to 180, 0 to pi. So sin theta I am keeping constant. Integral of r dr. Integral of r dr is r square by 2. Within the limits 0 to a into 1 minus cos theta d theta. So this is with respect to r, keeping theta terms constant. So this is equal to 1 by 2 is a constant. I am writing outside integral 0 to 180, 0 to pi. In place of r, I am substituting upper limit. What is upper limit? A into 1 minus cos theta. R square becomes a square into 1 minus cos theta whole square d theta. Lower limit is 0. So when I substitute in place of r 0, 0 square means 0 only. So here now this is a square is constant, a square by 2 into integral 0 to pi 1 minus cos square 1 minus cos theta whole square into sin theta d theta. Now we have to apply formula for integrating with respect to theta. So which formula we have to apply? So this is the important situation. We have to identify what is the formula involved in this question, in this particularly in this step. So 1 minus cos theta sin theta is there. So in last question also I explained one of the formula. If I take 1 minus cos theta is f of theta. If I take, that is integral of f dash of theta into f of theta power n d theta. It may be theta or r or x, anything variables. This is f of theta power n plus 1 by n plus 1. This formula now we are going to apply. How would you know this formula only involved here? The simple logic, 1 minus cos theta is f of theta. What is 1 minus cos theta derivative? 1 minus cos theta derivative is sin theta. So that's what there is a formula involved here. What is that formula? Integral of f dash of theta into f of theta power n. N is 2. So when I apply that formula, it becomes a square by 2 is a constant. So integral 0, this is f of theta, this is f dash of theta. 1 minus cos theta whole cube, n plus 1, 2 plus 1, 3 by 3, limits 0 to 180. So this is 3 constant right outside, that is a square by 2 into 3, that is a square by 6. 1 minus cos theta whole cube, 1 minus cos theta whole cube, whole power, that is within the limits 0 to 180, 0 to pi. Now it's time for applying upper limit minus lower limit. So that is equal to a square by 6 into, first I am writing theta is pi, upper limit, 1 minus cos 180 whole cube. This is upper limit minus lower limit. Lower limit means theta is equal to 0. So that is 1 minus cos 0 whole cube. So that is equal to a square by 6 into, we know cos 180 degrees and cos 0 degrees. Cos 180 is minus 1. So 1 minus of minus 1, 2. 2 cube minus cos 0 is 1. 1 minus 1, 0. So that is 2 cube. 2 cube means 8. 8 a square by 6. 8 a square by 6 means 4a square by 3. This is the answer. So once again, it is very easy to identify the limits and evaluate the integral. First of all, the given question is double integral of r sin theta dr d theta over the cardioid r is equal to a into 1 minus cos theta above the initial line. This is the initial line. This is the initial line. Above the initial line only I determine. This is above the initial line. Right. So here first we have to draw the rough sketch. From that only we can extract the limits where r running from where to where and theta running from where to where. So it's very simple. In polar form, this is the initial line which is the x-axis. Theta is equal to 0 to theta is equal to 180. This is a perpendicular line. Theta is equal to 90. This down is theta is equal to 3 pi by 2. Right. So here in this theta, in this figure, theta limits. How to draw this figure, that is also very important. So from the equation only I draw the figure. So here r, when theta is equal to 0, that means in this arc, when theta is equal to 0, r value also 0. That's what it passes through the pole. And it meets at theta is equal to 180 at the point 2a comma 0. So that's what here, this is the structure of cardioid. So in this cardioid, we have to take the limits. R limits are in terms of theta always. R limits 0. Here R limit starts from 0 to cardioid equation. That is a into 1 minus cos theta. And theta limits. Theta limits means theta 0 degrees. This is theta 180 degrees. It is from 0 to 180. That's what theta limits are 0 to 180. R limits are 0 to a into 1 minus cos theta. So as usually, first we have to integrate with respect to r, keeping theta terms constant, and then with respect to theta. First with respect to r, sin theta is constant. Integral of r dr. Integral of r dr is r square by 2. We know r square by 2, that is a formula, basic formula of integral of x power n. Integral of x power n is x power n plus 1 by n plus 1. That formula applied. Integral of r is r square by 2. So this 2 is a constant, that's what I wrote outside. In place of r square, I applied upper minus lower limits. Upper limit is a into 1 minus cos theta. So r square becomes a square into 1 minus cos theta whole square. Already sin theta is there, d theta. Now here this is the important step. We have to identify which formula is involved in this. So simple formula, if I take 1 minus cos theta is f of theta, obviously its derivative is sin theta. So f integral of f dash of theta into f of theta whole power n formula is there. Integral of f dash of theta into f of theta whole power n becomes f of theta whole power n plus 1 by n plus 1. I applied that formula only. Then it becomes 1 minus cos theta whole cube by 3. The 3 is constant outside. Already a square by 2 is there. 3 into 2 a square by 6. 1 minus cos theta whole cube. Then I have to apply the limits of theta, that is 0 to pi by 4. When I apply the pi by 4, cos pi, 0 to pi, sorry. So when I apply the upper limit pi, cos 180 degrees is minus 1. Already 1 is there. 1 minus of minus 1, 2. When I apply the lower limit 0, cos 0 is 1. 1 minus 1 is 0. So that is a square by 6 into 2 cube, 8a square by 6. So that is 4a square by 3. This is the answer. So finally I will explain one more problem. That's the last problem for this session, right? So one more problem which have the which have one region but limits are not given, same as the previous one. So here double integral, coming to the question, let I is equal to, given one is I is equal to double integral of r cube dr d theta. This is the given question. So where the region is bounded, where the area included the circles, r is equal to 2 sin theta and r is equal to 4 sin theta. Right, as usually we have to take initial line and perpendicular line, and r is equal to 2 sin theta, r is equal to 4 sin theta, which represents circle. r is equal to 2 sin theta represents circle. This is r is equal to 2 sin theta. R is equal to 4 sin theta also represents circle. That is r is equal to 4 sin theta. So this is theta 0, theta 180, theta 90 and theta is equal to 3 pi by 2. Again this is. So this is the figure. In this figure, it's very easy to say that where we have to integrate over the area included the circles. So in this area we have to integrate. In this area we have to integrate. So this represents what? R is equal to 4 sin theta and this represents R is equal to 2 sin theta. Inner circle represents R is equal to 2 sin theta. Upper circle represents R is equal to 4 sin theta. So in this region only we have to do. So this region is very clear to say that what are the theta limits, what is the R limits, are in terms of theta. So from this to this, that means from 2 sin theta to 4 sin theta, that is the theta limit, that is R limits. Then theta limits. Theta means it will start at 0 degrees and ends at 180 degrees. So that's what here, what are the theta limits and R limits? R limits are, so this is the area lies between the two circles. That's what R limits are, 2 sin theta to 4 sin theta. 2 sin theta to 4 sin theta. And theta limits are 0 to 180. 0 to 180. So, and r cube dr d theta. As usually, first we have to integrate with respect to r, keeping theta terms constant, and then integrate with respect to theta. So, that is equal to integral 0 to 180. Here integral of r cube dr. You know x power n formula. Integral of x power n is x power n plus 1 by n plus 1. Integral of r cube is r power 4 by 4 within the limits 2 sin theta to 4 sin theta. 2 sin theta to 4 sin theta d theta. So this is a 1 by 4 is a constant right outside. This becomes 1 by 4 into integral 0 to pi 4 sin theta whole power 4 sin theta whole power 4 minus 2 sin theta whole power 4 d theta. So that is equal to 1 by 4 into integral 0 to pi. So 4 power 4 256 into sin power 4 theta d theta minus 2 power 4 16 into sin power 4 theta d theta. If I take sin power 4 theta common, this is 1 by 4 into sin power 4 theta common. So that is integral 0 to 180, 256 minus 16, 240 sin power 4 theta d theta. So this 4 in 240, 60 times cancel, 60 into integral 0 to 180 sin power 4 theta d theta. So here there is a formula for sin power n. Particularly the limits are 0 to pi by 2. But here the limits are 0 to pi only there. Whenever the limits are 0 to pi by 2, integral of sin power n theta d theta formula is there. That's what here by the properties of integrals, integral 0 to pi, that is 0 to 180 degrees, can be written as 2 into integral 0 to pi by 2. So here what I am writing, the 60 is 2 into integral 0 to pi by 2. 2 into integral 0 to pi by 2 sin power 4 theta d theta. So that is this is the one of the properties of integrals. Integral 0 to 180 can be written as 2 into integral 0 to 90. So this is 2 into 60 120 integral 0 to pi by 2 sin power 4 theta d theta. Right, here there is a formula which will give the answer of sin power n theta, particularly in the limit 0 to pi by 2. So integral 0 to pi by 2 sin power n theta d theta is equal to Answer is n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 and so on. The last term is pi by 2. Last term is pi by 2. If n is even, it is pi by 2. This and if n is odd, all terms same, that is n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4 and so on. Last term is 1 if n is odd. This is the one of the important formula. If n is even, last factor is pi by 2. If n is odd, last factor is 1. Now here sin power 4 theta. 4 is even. That's what I have to write. Last factor is pi by 2 and n particularly 4. So now I am applying that formula. So that is equal to 120 into, so n minus 1 by n. That means 4 minus 1 by 4 into n minus 3 by n minus 2. 4 minus 3 by 4 minus 2 into, that's all. Next term will not get. Last term is pi by 2. Just I applied that formula. So that is equal to 120 into 4 minus 1, 3 by 4 and 4 minus 3, 1 by 2 into pi by 2. This 4 in this 120, so 30 times cancel, and 2 in this 30, 15 times cancel. So 3 15s are 45 by 2 into pi. So 45 by 2 into pi. This is the answer. So once again, here double integral, limits are not given, one region is given. That region is bounded by the area included the circles. Region given in the form of area included the circles. R is equal to 2 sin theta, R is equal to 4 sin theta. So here there is an important point. So 2 sin theta, 2 cos theta, we have to write vertically. Suppose 2 cos theta, 4 cos theta is given. Here 2, 4 radius, sin theta is given. Sin theta, here we know x is equal to r cos theta, y is equal to r sin theta. That means y coordinates given. That's what we have to draw the figure vertically. Suppose the same problem given as r is equal to 2 cos theta, 4 cos theta, the figure we have to draw on horizontal manner towards positive. So that is the important point. Here the given question having sin terms or cos terms. If it has sin terms, draw vertically. If it has cos terms, draw horizontally, because the simple point is x is equal to r cos theta, that means along x-axis vertically, y is equal to r sin theta, so that along x-axis horizontally, x is equal to y is equal to r sin theta, that means vertically. So it's very clear, sin terms are given, we have to draw the figure vertically, and cos terms are given, we have to draw the figure horizontal. And one more thing, r sin theta, 2 sin theta, 4 sin theta, how can we say that it represents circle only? That's what I said starting. So circle parametric equations, that is x is equal to r cos theta, y is equal to r sin theta. Suppose x square plus y square is equal to r square, x square plus y square is equal to r square. If I substitute that is equal to, if I substitute in place of x cos theta, in place of y sin theta. So if x is absent, then we get only y terms. Y is absent, then we get only x terms. That means x terms means cos theta terms, y terms means sin theta terms. Anyhow, only sin theta terms are there, we have to draw the figure vertically. Cos theta terms are there, we have to draw the figure horizontally. So this is the figure. From this figure only, we can extract the limits easily. So it's very clear to say that 0 degrees, 90 degrees, 180 degrees. This is the area bounded by these two circles. That's what our limits are, 2 sin theta to 4 sin theta, because r in terms of theta. And theta limits are from this to this, that is 0 to pi. So here 0 to pi. As usually the simple formula is r power n, that is r x power n. R cube is r power 4 by 4. When I substitute upper minus lower limits, upper limit is 4 sin theta, lower limit is 2 sin theta. 4 power 4 sin power 4 theta minus 2 power 4 sin power 4 theta. 4 power 4 is 256 minus 2 power 4 is 16 sin power 4 theta common. So 256 minus 16, 240 sin power 4 theta. 4 in 240, 60 times cancel into sin power 4 theta. So here we have one of the formula already explained. Integral 0 to pi by 2 sin power n theta. It has a dual nature. So whenever n is even, the last term should be pi by 2. If it is n is odd, last term should be 1. So here n is 4, that's what I applied the last term is for pi by 2, n minus 1 by n minus 3 by n minus 2. Simply numerators are odd terms, denominators are even terms. N minus 1, n minus 3, n minus 5 odd terms. Numerator is even terms, n minus 2, n minus 4 like that. So I applied that formula by the mathematical calculations. Finally I got 45 pi by 2. I hope everyone understood evaluation of double integrals in polar form. Thank you.